Right, so we've discussed stateless packet filtering, and as we mentioned before, right, the one that's doing the filtering is the ACL, access control list. Now, while it works, right, there are better ways or more stateful ways of managing access control. Remember, stateless meant that the ACL couldn't remember if somebody came in on their way out, they couldn't just let them out because they remembered them. They were keeping no track of who was coming in and out. They would just check everyone indiscriminately. They would check all the packets, right, indiscriminately. There is a more efficient way, and that's by being stateful. That's when you actually keep track of who went in. So when they're on their way out, you can actually allow that response to make its way to the origin. Let's discuss this in more detail, though. So, uh, another method of controlling access is through security groups. So these are the stateful control systems. If ACL is stateless, security group does the same thing, but it's stateful. So it's a virtual firewall that controls inbound and outbound traffic for an Amazon EC2 instance. So same as ACLs, but in this case, we're going to add the stateful ability to this bouncer or traffic control officer, whatever you want to call them, right? And we're going to definitely use an analogy to put into perspective. So they're in charge of checking a packet's permissions to see if a packet will be allowed or denied entry into the network. By default, a security group denies all inbound and inbound traffic and allows all outbound traffic. So anything on its way out will be allowed to leave, but coming in, right, unless you explicitly configure the security group, nothing's going to make its way in. So once you add custom rules, then you can determine, right, which type of packets are going to be let in. If they're not on that rule configuration, if the packet doesn't pass that check, then of course it will be denied. So similar to the passport control officer, now we're gonna use an analogy of a VIP guest list at a club. So the security group is like the bouncer, right? So if you're allowed in, you can freely leave and come back without needing to show your ID again. So you're on the list, bouncer lets you in. The bouncer is not going to check for your ID again on your way out. Once you entered the club or subnet, the bouncer is not worried about what you're going to do on your way out. So this is exactly like security groups. Because the bouncer is in a sense remembering that you came in, then we would call this stateful. If you never entered in the first place, you can't just walk in without being on the list. So yeah, if you weren't at the club, they're not going to let you in. If you're on the list, they'll let you in, and then you can exit whenever you want. So the bouncer allows those in the club to exit freely because they can remember who was allowed in. For this reason, security groups are called stateful because they remember. That's the stateful part. So when we talk about stateful and stateless, stateful means they're keeping track of the state. They're preserving the state. They're remembering what happened in a previous state. So that's why it's called stateful. So they remember previous decisions made for incoming packets, just like the bouncer remembers who came in. They're like, oh, I saw you come in. Of course, you can go out. I'm not even going to check you, right? I let you in already because you were on the list. So security groups perform stateful packet filtering. So rather than stateless packet filtering of ACLs, so they do remember previous decisions made for incoming packets. Consider the same example of sending a request out from an Amazon EC2 instance to the internet. So yeah, let's say your instance is asking an API, right, an external API on the internet for information. So that would be an outbound request. So when a packet response for that request returns to the instance, so it asks the API on the internet, hey, give me some weather data. The weather data makes its way back into the EC2 instance. The security group actually remembers that that response belonged to that request. So it's not going to, check its ID again. It already knows it makes its way in. So that stateful component, right, is more efficient. There's less checks because it just already remembers that response had a corresponding request. So the security group allows the response to proceed regardless of the inbound security group rules. Remember, request and response, right? They're like a pair. It wouldn't make sense to treat them differently, right? If your instance was making the request, of course I want the response to make its way in. I shouldn't have to check my entire list, right, to make sure that it is allowed in. So yeah, let's look at stateful packet filtering. So I'm leaving, but I'll be right back. Okay, I'll see you when you get back. The door attendant, right, or the bouncer. Hi again, I'm back. Oh, I remember you. Go ahead. Right, that's good customer service, right? Well, that's the same with security groups. They're going to offer that greater efficiency in access control. So with both network ACLs and security groups, you can configure custom rules for traffic. So they have that in common, right? ACLs and security groups. But the ACLs don't remember, the security groups do. So as you continue to learn more about AWS security and networking, make sure you understand the differences between network ACLs and security groups. So these graphics, right, are a great way to simplify those differences. So a little bit of review of the components we've covered. We talked about 4 of the key VPC components. We talked about private subnets. So those are private resources, typically sensitive customer data. We have our public subnet. So you want somebody to come into your network, right, to your virtual private cloud. If you want it to support customer-facing requests and traffic, then you're going to go with public subnets. So that's typical, right, of an e-commerce website. Your homepage shouldn't be private, right? You shouldn't decrease access to your customers. And then we have virtual private gateways. So that creates a VPN connection between the VPC and an internal corporate network. So it's a special type of gateway when you don't want to connect to the broader internet. You just want to connect to a private network. It could be an on-premises data center, or like here they mentioned the internal corporate network. And then, of course, we have AWS Direct Connect. So that's a service that allows you to do the same thing as the virtual private gateway, right? It manages virtual private gateways for you. So establishes a dedicated connection between an on-premises data center and the VPC. So these are kind of the same. This is just the AWS version of virtual private gateways. All right, so next up, we'll be discussing global networking.